Hi, everybody, and welcome to Monday, August 28th. And I'd like to make a few remarks about the difference between absolute pressure and gauge pressure as a result of some very good questions that were brought in online yesterday evening, Sunday night. And so I've made a few PowerPoint slides, but I want to go live and show you some things. So basically, we're going to try to talk about some details of this pressure gauge, how to read this pressure gauge, what it's all about, and how it relates to your thermo class. So let's see, I'm going to share my screen. And I'm going to go to PowerPoint. And I'm going to hit slideshow. So don't worry, I'm not going to drag you through lots and lots of slides. But here's what I want to cover today is what is gauge pressure and what is absolute pressure. A number of very good questions arose from that. And so I've got a little bit of a personal quiz for you watching. 3 questions. And so when I ask the question, just sort of be honest with yourself. Try in your head to answer the question as best you can. If you cannot, that's okay. That's okay. But we'll try to get you up to speed on some examples of absolute pressure and gauge pressure. Okay, first question about what is the absolute pressure of your surroundings? What's the pressure around me? So on the slide, what's the pressure inside this room that's shown on the slide? So think about that just a little bit. Come up with a number and some units. Think about it. A number and units. Okay. The answer. The absolute pressure in this room is about 14.7 psia. That's so notice here, pounds force per square inch. PSIA, that's absolute pressure. Pounds per square inch, absolute. Okay. Or in SI units, it's about 101 kPa. That's kilonewtons per square meter. That's absolute pressure. And so if you didn't know both of these, I want to suggest that you commit those numbers and units to your memory. It's really going to pay off for you as you go through the course. What good does it do you? Well, in your homework problems and your engineering problems, you're going to be given pressures. And at least if you've got these in your head, at least you can compare the given pressure to atmospheric pressure. Is it higher than atmospheric pressure? Lower? Is it a high pressure? Is it a low pressure? Things like that. So that'll pay off for you if you can memorize these 2 numbers. Yesterday I mentioned, so I was in high school in 1969, 1970, and this was drilled into my head when I took physics. Absolute pressure surroundings about 14.7 psia. Second question. What is the absolute pressure outside this astronaut's spacesuit? So outside the spacesuit, what's the pressure? So think about that. What's the absolute pressure out there in outer space? Okay, answer is the absolute pressure in outer space is 0. There's an absence of pressure in outer space. Okay, there's no atmosphere out there. In fact, there's an absence of pressure because there's an absence of mass in space. There's no gas floating around there, no oxygen, no CO2, no hydrogen, no nothing. Okay, so the absolute pressure in outer space is 0. So now you've got 2 things. You've got 0 absolute pressure. You have a feel for that. And you have 14.7 psi absolute around here on Earth, around just about everywhere on Earth, around 14.7 psia. Third and last question. Think about this. What pressure do you put in your car tire? Or if you don't own a car, what pressure do you put in your bicycle tire? So just think about that. When you go to fill your tire, you're a little slack on air in one or the other of those, charge up the pressure. What set point do you set it at? Okay. Here's the answer. Depends on the car and your bicycle, doesn't it? In a car tire, depending on the type of car, you're looking at about 30 to 40 PSIG when you go and you add air to your tire. 30 to 40 pounds per square inch gauge. Pounds per square inch gauge. And you measure it with this pressure gauge, okay? Or for bicycle tires and sometimes with car tires, you can measure it with this kind of pressure gauge. So you're going to put that on your tire, and then the little stick sticks out, and then you can read what your pressure is once the stick is stuck out. Okay. 30 to 40 pounds. Oh, and jargon. So we engineers, folks say, how much pressure do you put in your car tire? Oh, I'm going to put in 32 pounds. Well, see, that's jargon, right? So really what we really mean is I'm putting in 32 pounds per square inch gauge pressure as read on this gauge or as read on this gauge. 32 pounds, that means 32 pounds per square inch gauge. On a bicycle, there's a big range, isn't there? The range on bicycle tires is somewhere between 22 and 130 pounds per square inch gauge. People say, well, I'm going to, I think if you have a bicycle, say that's designed to ride those big fat tires for riding on the beach, the sand on the beach, you're looking at a lower pressure, big tire, big surface area. For a road bike, very thin tires, sort of a minimum of contact area with the road, you're looking at up to 130 pounds per square inch gauge, or in jargon, we say 130 pounds, depending on the type of bike. Okay, how did you do on the quiz? Good, I hope. All right. Now, so again, we're going to go live here in a second, but here's our pressure gauge. It's kind of blurry, but my pressure gauge I'm holding up is very similar to the pressure gauge shown on the PowerPoint slide. So let's look and see what this pressure gauge looks like with the dial. It's calibrated or it's labeled in both English and SI units. Okay, here on the slide, the red is going to be in kPa gauge pressure. So notice the units, kPa. It's up to you as the engineer to know that what you're measuring with this gauge is gauge pressure. Okay. Or in English, PSI, pounds per square inch. And you as an engineer, you know that what you're doing is you're reading pounds per square inch gauge. Okay. And here's the way, this is called a board-on tube pressure gauge. So I was able to find this picture of what's connected to this dial that makes it work. And so this is sort of a sketch of what's going on inside this gauge. And so you see that we've got our pressure tap. Here's our pressure tap right there. Pressure tap. So this would be connected, say, to a tire or a vessel. Okay. So the pressure of this vessel is filling the inside of this sort of curvy tube. It's called a board-on tube, okay? And so what's on the outside of this board-on tube? The atmosphere. So the atmospheric pressure surrounds the outside of this board-on tube. Inside the board-on tube is going to be a higher pressure, okay, inside your tire. And so as an engineer, you can figure out what's going to happen. The higher the pressure, the more the board-on tube wants to straighten out. So it's curved. So the higher the pressure, the board-on tube wants to expand. It wants to straighten out because it's in a curve. And so you can see that there's a little linkage involved here, little gears and teeth that are hooked up to a springy dial indicator. So there's a spring to return it to the zero position. So essentially that's the way a bored-on tube pressure gauge works, is you have a high pressure above atmospheric pressure inside this curved tube working against atmospheric pressure outside. And that's why we call it gauge pressure. So do you see that in a lot of ways, it's kind of like a pressure difference. Gauge pressure is a pressure difference higher than the atmospheric pressure. Okay, got it? All right. And so mercifully, now we're going to go live. Okay, so I'm going to quit sharing my screen. And okay, here we go. Okay, so I'm back to full screen. Okay, and now kind of like what we did Sunday, I'm going to try to hold up this gauge, and then I'm going to ask this. We don't have any students online right now, but see if I can get this to come into focus. If I can hold it still, I'm having a rough time here. Here we go. Okay, so the camera is focusing on the gauge. And like I asked the students, I said, now, what is that reading? What does it read right now? I'm hooked up to, I'm basically measuring here's my pressure tap. Okay. Wow. What is it reading? And the student says, oh, it says 0. That's correct. 0 pounds per square inch gauge. We're measuring that's the atmospheric pressure. 0 pounds per square inch gauge. Okay, got it? Now, so when we put this pressure tap and measure something that it's higher than atmospheric pressure, this thing's going to start reading. Okay, and so I couldn't lift a car tire on my own nowadays, so I brought in a smaller version of a car tire. Okay, well, just so do you see that this thing is going to remember what pressure it measured? So here's our pressure gauge we use for a bike or this tire. I'm gonna, okay, here we go. So I hope I don't lose much air out of here. Okay, and so I've got, darn it, 35, and so it's registering 35, right at 35. Okay, so that's going to be what the pressure inside this tire is, 35 pounds per square inch gauge. 35 pounds per square inch gauge pressure. So if it were a homework problem, so what's the absolute pressure inside this tire? What's the absolute pressure inside the tire? I'm not measuring that. I'd calculate it to be 35 plus 14.7. Okay. Now let's see if we can do something similar with this pressure gauge. So that's really the purpose of this little demo here. And now my trick is to get everything situated. So, okay, I haven't pushed the pressure tap in yet. I'm still having a hell of a time getting lined up. Okay, the black numbers are pounds per square PSI, and the red numbers are KPA. And so let's see if I can, okay, here we go. And here we go. I just took the tap off, so it went back to 0. Let's try it again. Okay, so this gauge looks like its measurement was 30 PSI. And probably the reason was that I've let so much air out of the tire during my measurement process that we've lost 5 pounds just by making the measurement. Well, shame on me, not doing so good on that. But we started out at 35 PSI or 35 pounds in the tire. We ended up with 30 PSI. Oh, and now we're back to 0. The pressure gauge is back to reading 0 because we're measuring the pressure of the atmosphere. Okay, you got it? Okay, I hope that demo gives you more of a physical feel for what we have going on absolute pressure versus gauge pressure. Okay, and so now some conclusions. units of pressure. Now, in your class, you're going to have a mix of English units and SI units, so units of pressure. PSIG, that's gauge pressure, units are pounds force per inch squared. PSIA, the units are identical, pounds force per inch squared, but this is absolute pressure. So I hope that you've got a better feel now for the difference between a gauge pressure and absolute pressure. Okay. Similarly, in SI, notice here, we don't say KPAA and KPAG. We could just write out KPA gauge pressure, units KPA, or kilonewtons per square meter. Absolute pressure, KPA absolute, KPA equals so many kilonewtons per meter squared. Now, when you're doing your homework problems and you're given a pressure in KPA, let's say 250 KPA, that's going to mean absolute pressure. So in general, if your textbook says gauge pressure, then it means gauge pressure. But if it doesn't say anything, that means absolute pressure. Okay. Another takeaway, statements about the atmosphere, the pressure of the atmosphere, the pressure of our surroundings. The pressure of our surroundings is about 14.7 psia. Okay. As you go higher in elevation, that pressure drops, doesn't it? And so probably in Blacksburg, you're looking at about 14 psia, but let's just, in general, at sea level, atmospheric pressure is around 14.7 psia, absolute pressure. The pressure of our surroundings, is 0 psi gauge, just like I demonstrated with this gauge, okay? And then finally in SI, the pressure of our surroundings is about 101 kPa absolute pressure. Pressure of our surroundings is about 101 kPa absolute pressure. Okay, statements about tire pressure. In my case, I use a pressure gauge. Okay. Use a pressure gauge to inflate my tires to 32 psig, or in jargon, 32 pounds. Okay. Now, that's gauge pressure. If you're asked, well, what's going to be the absolute pressure inside your tires? Well, it's going to be 32 plus 14.7 or 46.7 psia on the inside of the tire. Absolute pressure on the inside of the tire, 46.7 psia. Outside the tire, there is a pressure pushing on the rubber tire, and that's 14.7 psia. Inside, pushing outwards, 46.7 psia. Outside the tire, pushing in, 14.7 psia. And then I did a little conversion. I did the conversion. And so the conversion of 32 pounds per square inch gauge is 221 kPa. So if I wanted to say SI, if I wanted to go to Canada, I would inflate my tire to 221 kPa. That's their settings in Canada, gauge pressure. And so this is going to result in an absolute pressure inside the tire of 221 plus 101 kPa absolute pressure. Okay. And let me check one. Yep. That was my last slide, which I'll leave up here a little bit. I want to recommend that you learn this, put this in your memory bank immediately. 1 bar equals 100 kPa. Put that in your memory bank. 1 bar is 100 kPa. A bar is a unit of pressure. It is rarely used in industry. In 35 years of working in industry, I might have used bars of pressure once or twice when I was having to look up something in a book or something like that. Okay. However, the units of pressure, bars, is commonly used in research labs and textbooks. So you need to be able to jump back and forth between bars and kPa, but when you're working for a living, recognize 1 bar is 100 kPa. Why am I going on and on about this? Most of your engineering problems, even in the textbook, pressures are expressed in kPa, absolute pressure. Okay. However, if you go to the back of your book and you look up pressure, various various properties are tabulated for things like steam and water and air, carbon dioxide, nitrogen. And typically when pressure is involved in tabulated values, the pressure is listed in bars, in bar. So that's another reason that you need to be able to go back and forth quickly between bars and KPA. So many students that I've worked with both in class and tutoring is if they don't memorize this, they spend so much time simply working in between these two units that they've lost time in sketching and figuring out the problem. So that's why I did that. Okay, so there we go. That is a quick video about the difference between gauge pressure and absolute pressure. I hope you have a little better feel for how this pressure gauge works. It's a board-on tube pressure gauge. These things are all over the place. You're going to see these in labs. Certainly they're throughout industry. They are very cost-effective ways to measure pressure. Board-on tube pressure gauge. Remember here, it's showing 0. That means it's correctly reading that the atmospheric pressure is 0 psig. Okay, I hope that helps and hope to see you live sometimes. Don't hesitate to join in the online sessions.